Hello. So this video is for chapter 14, database programming. So let me share my screen and get started, and then we'll see what we're going to be doing here. So I think that's the screen. So, all right, I've typed in the handle and I've gotten to all the repos. So we're going to find database programming. There we go. It's going to create a repo for me. Just 1 second. All right, so there we go. My repo is created for me. So before we get started, let me explain what a database management system is. Database management system is a software, a big software that manages large collections of data. And this data can be any data type. And this is an enterprise solution. So if you have ever heard of Oracle, Oracle is a database management system, and MS Access, Microsoft Access, or MySQL, or PL, or DB2, or PostgreSQL. These are all big database management systems. And all these database management systems have one thing in common, that they use a common language called SQL, or almost SQL-like language, with slight variations or slight differences, but mostly all of these use a SQL language. So in this chapter, we are going to be seeing a brand new language other than Python. We're going to see a brand new language called SQL, and we're going to see about maybe 10-15 statements, SQL statements, on how to add data, delete data. So far, we have seen creating data, retrieving data, we have seen updating data, and then we have deleting data. These four operations, the CRUD, the CRUD operations, are intrinsic to a database management system. The beauty of database management systems, however, is as an end user, as a programmer, you really don't have to worry about the internal logic. By writing simple English-like statements, you can accomplish a lot of things that we've done. So for example, when we were adding a student, we were calculating the next CWID, and that code was different for when we were using a dictionary versus when we were using a list. So, but database management system has an underlying programming language. So for example, if you take Oracle, Oracle is written in C. So C is using some kind of data structures that we don't have to worry about, and it's going to calculate all of that for you, and it's just going to, all we need to know is the statement on how to do it. So we'll understand all that as we get move forward with the SQL statements. But a little bit of history about database management systems, why they came into existence. Back in the old days, they used to use file systems to maintain data. So for example, a university's data, where you have students, you have employees, you have a bunch of courses, and then who is taking what courses, who is teaching what courses, and then the student's fee, who has paid, who has not paid, all of this information, and then a whole lot more is or used to be stored in what's called a file system, or VSAM files. The problem was, as the requirements got bigger, maintaining all of these files got so much more cumbersome. So if you recollect, in our chapter 5, we've seen files. And in that, when we were trying to insert a new student, there was no way we could determine that we were inserting a duplicate record. Right. So for ideally, a student should not have more than one. Two students cannot have the same CWID. But when we were using our files, we could not, without a lot of complex code, figure out that part. So that's why file systems were starting to fail, and then came the need for something more robust, and whatever the data structures were, I don't care if the student data is stored in a list or a dictionary or whatever C language data structures are, I just need to know how to add a student. So it came to that point. So database management systems kind of evolved, where they provided like an abstraction, a level of abstraction to the end user. Hey, you don't need to worry about the logic. These are the few statements that you need to know how to do the operation. Everything else, the heavy lifting, will be done by the database management system. So Like I said, to be able to write anything, to be able to tell the database management system on what to do, we use what's called a structured query language, or SQL or SQL. So this language is very similar for MySQL databases or Oracle databases, or in this case, for this class, we are going to be using what's called a SQLite database management system. Lite itself tells us that it's a lightweight database management system. So unless Oracle, which is a full-blown enterprise proprietary database management system that runs on servers, SQLite is a really lightweight database management system that can run on small servers or even a desktop. And the beauty is, when you install Python on your computer, or in our case in Replit, if you have a Python container, it comes installed with that. So that's why for the scope of this class, we will be using SQLite as our database management system. And for that, to be able to use that, we simply import SQLite 3. That is the Python statement we have to do to be able to use SQLite database management system. So a database management system is a big collection of multiple tables. So to make it easy, or to make it more visual for you, I'm going to say, think of an Excel file, how you have tables. If you want to store some data about a student or multiple students, then you create a table. Each column will designate what data you're storing, and each row will tell you which student it is for. So very similarly, database management systems also have an abstraction of a table. So for example, if you want to store the data of say 4 students in this case, and you want to store the name, major, GPA, and CWID. So when I look at this, I can, to use the appropriate terminology for a database table, I would say this whole thing is a table, and each of the row is called a record, and each of the column is called it's a data item. So, or a data attribute or a characteristic. So to design a database or design a table like that, even in Excel, you have to specify this is 2.453. This is the numeric data that is being stored in this column. Then you have to tell Excel what type of data it is, and you have to say a real number, or you have to specify the number of decimals. So very similarly, when we design a table like this, we have to specify to the database, hey, I am creating a table. It'll have 4 columns, and each of these columns will have its own data type. And the data types in SQL, or database management system SQLite 3, are different from Python in the way that we define, or that we design. So for example, if I wanted to do a string in Python, we did what is called an str, right? But here in SQL, we would say text. In Python, whatever we used to call float, in SQL, now it's real. What was int for integer in Python, it's become integer, full spelled out, and whatever was a none type in Python is a null here. And there's an additional one, which is a blob or blob that we use in SQL, which it can be even an object. If you create a student object, you can store that in this column as a blob. So these are the data types that we know or compare and contrast with Python. So you can read through all of these. I'm not going to go over all of these. So those are, as of now, those are things that I need to specify to the database, that I have a table and have to give it a name. So basically, I'm storing student data. So I'm going to call this students table, or simply students. And then I'm going to say my students has 4 columns, named name and major, GPA, and CWID. And the name is a text, because that's what we're calling it now in SQL. We're calling it a text. We're not calling it a string anymore. And major, by the looks of it, is also a text. GPA is real, because that's what we're calling it in SQL, not a float anymore. And then CWID, well, it could be an integer, it could be a string. Let's call it a string for now. Just for now, we're going to say CWID could be a string. So that's a preliminary design of how I can tell a DBMS to create me a table to start storing the data. Additionally, I can specify more information about the table, and they are called primary keys, identity columns, or null. So primary keys are any column by which you can retrieve a unique row is called a primary key for that table. So for example, in this case, let's say social security number. Given a social security number, you will only have one person with that number. So social security number, can we call that a primary key for all US citizens? Yes. So as a student, you have CWID. Given a CWID, there's only one student that you can uniquely pull up, and that's why CWID is a primary key. So when you're designing a table, it's desirable. It is very good to define a primary key. That way you eliminate duplicate entries for stuff. So how can we design a primary key in database management system? We'll see that when we write our first SQL statement. But before that, we'll just understand the concept. So contrasting to, or not contrasting, conversely, identity columns are columns that could be that also retrieve unique rows, but they have no relationship to the data. For example, social security number has a relationship to you, that's your social security number, but ID number are system generated. So for example, if you book an airline ticket, you get a confirmation code, right? That uniquely pulls up your reservation, but that is not the data that you have provided to the system. The system has automatically generated it just so it can retrieve your reservation uniquely. Same thing with Amazon product order or something. If you order something on Amazon, it'll create an order number for you, and if you call the customer support, you just give them the order number and they will uniquely pull up your order. So these are called identity columns, which are generated by the system automatically every time a new row is inserted, and the user doesn't have to provide that data. So those are called identity columns. And null values, sometimes you don't have data, and you may not have data in your table for a legitimate reason. For example, Jane Doe in this case doesn't have a GPA, and that could be legitimate. Maybe she's just a first-time freshman, she's just taking her classes, and she doesn't have a GPA yet. So in that case, yes, you don't have a data there, and that would be a null. Null data can be stored in there, or you may not have the data for that person. So for example, if you're doing it for a male and the column says a question relating to that is related to a female, that column will be empty for a man because it's not relevant. So if the data is not relevant or not available at this point, then we store what's called a null value there. So now let's go ahead and learn how to design tables. So knowing all of these, so we know columns, we know data types, we know what primary keys are, and we know null values. So with this information, how can we write our very first SQL statement to be able to create a table? So that's what we're going to see. But before we go there, I want you to understand visually what SQLite 3, when we do import SQLite 3, what is happening. So Python code or our application, so the program that we write, the .py file that we write cannot directly communicate with the SQLite database management system in the backend. So that's why we use a SQLite 3 module, and anything that we want to tell the SQLite database management system, we kind of create strings in Python, and then we pass it to this module, and this module translates it to the appropriate statements, and it sends it over the SQL database management system, and the DBMS responds, and the SQLite 3 changes that or translates that response and gives it back to the Python application. So let's see how that happens using our code. So what was the note here is, think of this, the SQLite module, think of this. or the cursor we obtain. Okay, here, just one more second. So we import a module called SQLite 3 that acts like a translator. It relays MySQL statements stored in Python string to the DBMS and relays the responses back to the Python application. So the first and foremost thing that a SQLite 3 does is it creates a connection to the database. So basically, a connection is established, and then from that connection, what is called a cursor is obtained. So this cursor, think of it as your file pointer. So remember how I told you the file pointer encapsulates a lot of information. It encapsulates the file name, the file type, and a lot more other information. For this class, we've only used the file name and the mode in which we were opening that file. So cursor, very similarly, also encapsulates a lot of data. It stores the data about what database are you opening, what are you trying to do with it. So think of it as a file pointer. So, okay, so to be able to do anything, to write any SQL statements, first we need to be able to talk to the database management system in the background. So the very first step we have to do is to import the module that helps us talk to the database, which is SQLite 3. So the second step we have to do is we have to connect to the database. So think of this connect statement as our file open. When we were trying to open a file, we were specifying the file name. Here we're using the connect statement that is available in the SQLite 3 module, and we're obtaining what's called a connection variable. So .conn from this point onwards is going to be my connection detail. And using that connection, I'm going to obtain the cursor. These are the first 3 steps, mandatory steps you have to do to be able to do any SQL statements. Okay, so the third step is I am obtaining a cursor using this connection. So this variable will always be the same. So if I say this is C or C1, then this becomes C1. So using this C1 object, I am calling the cursor method, and I'm creating a cursor, and I'm storing it in a value CUR, or you can call it whatever you want. So for the scope of this class, I'm just going to keep it easy and simple. So my connection variable, I'm always going to use CONN, and then my cursor variable, I'm always going to use CUR. So these are the first 3 important statements. All right, so then after this part, I am going to pivot. And so far, these are all Python statements. We still haven't looked at a single SQL statement, and we will get to that in just a second. And before we can do that, and I'm going to use the last statement. So any operations that I'm going to do on the database. So I have connected to the database. I got the cursor, which pretty much is like my file pointer. And any operation that I want to do will be here. And then after all my SQL operations are done, I'm going to have to commit all of these changes back to the database management system. So commit is pretty much anytime you're trying to manipulate the data inside the database management system, you have to, yes, I am sure I want to make these changes, and then commit those changes. And the last thing you can do is you can close the connection. So this is very similar to closing a file. So there's one additional step here is to committing our changes. So if you don't make any changes, or if all you're doing is retrieving the data, honestly, even if you didn't have the commit statement, that'll still be okay. So one last thing I want to tell is, so when you use the connect method and you specify students.db, for no other reason, I said .db doesn't have to be .db. It could be any extension that you want, but I'm going to say db because it's database. So I am trying to maintain a database of students, so I'm calling it students.db. Okay, so when I use the connect method to create a database called students.db, if it doesn't exist, Python will create it for me. It will not give me an error here. So anyway, so these are the 5 Python statements: 3 before we do any operations, and 2 after all the operations are performed, that I will have to incorporate into my program to be able to do anything. All right, so without further ado, let's start looking at the SQL statements here. Okay, so the SQL, now we're talking about SQL. This code will not run in Python as is, but first let's learn the SQL statements, and then we'll see how to pass it to Python to be able to send it to the database. All right. So the SQL statement to create a table. So we have seen our table in our previous screen. It was the table's name. Like I said, we have to create the name of the table, and then we have to create 4 columns, and we have to specify what each of those column types are. So the SQL syntax is create table. Now the create table has to be verbatim. It can be uppercase or lowercase. So MySQL or SQL is not case sensitive. It is case insensitive. So create table all lowercase is the same as create table all uppercase. But all of these are in blue. All of these are that are in blue are inbuilt SQL commands. So you cannot create a table named table because that's already used up as a reserved word in SQL. So I'm creating a table named student, and I open parentheses, and however many columns that I have to specify each column name and its data type with a space, and then put a comma and do the same for every column. So because I showed 4 columns, and I don't think I'm including any CWID column here yet. So I'm going to say name is a text, major is a text, phone is a text, and GPA is real. I'm not saying float because float is Python. Real is what MySQL understands. So the note here is all the words in uppercase are SQL keywords. SQL is case insensitive, but I want to see the best practice is to use the uppercase. So industry standard is whenever we write Oracle or MySQL statements, we try to keep all the MySQL words in uppercase. So that's that. And so now to this statement. Now this is my very basic SQL syntax, and it's going to give error here on the Python screen, which is okay. And then to this, if I want to define CWID as a primary key. So remember when we talked about primary key, we said any column that will uniquely retrieve the entire row is called a primary key. So CWID naturally is my primary key. So to be able to define CWID as a primary key, I can simply put another comma, and the 5th column is going to be CWID. And CWID is a text. For now, I'm going to define it as a text. And then I use the reserved word primary space key. So the database understands, okay, so I cannot allow multiple CWID. So if the user tries to enter another person with that CWID, the database itself will throw an error and say, no, 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 you cannot do it. So as an end user, we don't have to make that check anymore. So another thing is we talked about null. So when you define a primary key, it's a good practice to use the not null constraint. So not null means you cannot allow any blank value. So primary key cannot be a blank value. So by forcing it not null, we're forcing the user to have to enter a field. So think of this as when you're filling out a form and you have required fields for those forms. If you don't fill out that form, it's going to throw up an error and says, hey, this is a required field that you have to fill. So similarly, if you specify not null on a table, the database management system will not allow you to insert an empty value for this column. Similarly, why can't I do the same thing for name? Yes, I can do that if I want the user to if I'm forcing the user that he must enter a name, then I can do the same thing for name also, or major, or phone, or GPA. But in this case, the way that I've designed it as of now, it will force the user to enter at least the name and the CWID. Major, phone, and GPA can be blank, can be null. Okay, so far that's my syntax. So now, hey, remember how we did next CWID calculation? Anytime we were inserting another student, the user didn't provide the CWID, we just used our own calculation to calculate the next CWID. So how about we do the same thing and not have the user enter it for us, but it be designated to us? So how can we make that possible in a database system? Very simply, if you change the CWID text to integer, and you design it as a primary key, not null, database management system will automatically, if you don't provide a CWID, it will increment it to the last available CWID. Last inserted CWID will be incremented by 1, and your new record will have that CWID. So there you go, how easy it is in a database management system versus another programming language. So the last thing we're going to add it here is if not exists. So what if this table already exists and I'm trying to create this table again? That's when MySQL will give us, oh, not MySQL, database management system, or in our case, SQLite will give an error. So to ensure that that doesn't happen, I can specify what is called if not exists. So when I do if not exists, then it will create this table only if it doesn't exist. If it already exists, it just simply ignores it. It will not try to override it. It'll let it be and ignore the creation of the table. So now we have to put all of this in Python. So how do we do that? We put it in a string, and then we'll call it our SQL string, okay? So our SQL string is this big long create table statement. And guess what? I am using my 3 single quotes or 3 double quotes if you want to do that, because I want to space out. I want to break down my statement into multiple lines and it makes sense to me like this. So there you go. That's my SQL string. So this, I'm going to move it back. So remember where we said any operations, they will go there. There you go. I placed it inside that. And one additional step I have to do here is what's called the execute method. But I can only do execute with the cursor. So that's why we need to get a cursor. Here, using the connection variable, I got the cursor, stored it in a CUR variable, and now any operation, most likely we're going to be doing execute and fetch all. To be able to do that, we need the cursor. So whatever cursor name you specify, it's going to be here, dot execute. So just creating a SQL string is not enough. We have to actually execute it. So let's see what happens before we get to the deleting table. We're just going to simply go ahead and execute and see what happens. So right now, all I have is main.py and my pretty print file. So if I execute this code, it should, number 1, because students database doesn't exist, it is going to have to create it for me. And inside that, it will create a table. Whether it created the table or not, it's really tough to see. But there you go. If it didn't give you any errors, oh, it gave me an error. So let's look and see what the error is. If not exists. Oh, wrong place. Create table if not exists, and then the student name. Sorry, bad. So now if I run it, it created the students.db. If you open it, really, you cannot see a whole lot. All that data is so encrypted, but I'm just going to assume that we were able to successfully create the table. So now that we've created the table, let's try to delete the table and see the statement to delete the table. And very, very simply, the statement to delete a table is going to be, so I can create another SQL string and put it inside single or double quotes, and that's the SQL statement. And I'm going to use the execute statement from Python using the cursor, and then I'm going to delete it. So there you go. It ran without any errors. So it created a table, it deleted the table. Right now it's not much, but we will see more operations and see how data can be inserted into this table, how data can be retrieved, how it can be deleted or modified, and all of that in our next lecture. That's about all I wanted to cover. Hello. So this is the second lecture video for Chapter 14, Database Programming. In our previous lecture, we have seen how to create a table and we've seen how to delete a table. So in this lecture, we're going to be seeing how to insert data and how to modify data and how to delete existing data from a table. Before we continue any further, I want to remind, or I want to reiterate if I haven't said it before, when you're creating a table, one thing to note is all the column names should be one word. So a column name cannot have a space. So the same rules that apply for Python variable names, most of them apply here. that you cannot have a space, you can have an underscore, you cannot have a hyphen because SQL is going to think you're trying to do a subtraction operation. So mostly it's underscores that we're going to be using for this class. If you want to have multiple, like you want to say book name, you can do book underscore name, but you cannot say book space name. So that's the one thing I wanted to highlight. So all right, so let me go ahead and write the import statement and catch up to where we stopped last time. And then I'm going to get the connection by connecting to the college database. And if it doesn't exist, it will create it for me. And I'm going to get the cursor using the connection. So this is where we kind of stopped, and all the operations kind of go here. And we're going to use the connection to commit the changes. And then the last thing, we're going to use the connection to close the connection. So first off, we wanted to create a table. So let me grab the code for that one. And then I'm going to say, okay, create a table, student major phone C, and all of this. And then it'll create me a table. Good deal. So now I have the table. How can I start putting in data? Because right now all it is a blank table with a shell ready to take in data. So that's kind of what we're going to see in this lecture. So we have what's called an insert statement. Once you create a database file and connect it, you can add more rows to the table. So the insert statement syntax is insert into. You have to use those verbatim. And then here comes the table name. So in this case, it is student. And then the column name, column, how many ever columns will all go in one set of parentheses, all separated by one comma. So a comma. So let's go start writing our insert statement. And I'm going to call it my SQL str again, because I've already created my table and I've executed it. So I really don't have a need for that variable. So I can reuse it and I can rewrite it as many times as I want. So now in this, I'm going to say insert into, that's verbatim. And then whatever is the name of my table, deal. And then whatever or however many columns I have, I can use those in comma separated values. Again, all of these uppercase, lowercase, it really does not matter because SQL is case insensitive, so it really doesn't care about the case of the column names. So oh, I already have the insert statement in here, but anyway, so values would be whatever the corresponding values for this would be. So name would be whatever the corresponding name. Again, they have to be in single or double quotes. So I'm just going to grab this insert statement from here. So that corresponds to the first value. This corresponds to the second value. So as you can see, we have created our columns in this particular order, but the insert statement columns can be in any order as long as your values also match up in that order. So that's the beauty of SQL. It's really simple. It really makes it easy on us. We don't have to remember any particular order in which the columns were created. As long as the column names are the same, their case also doesn't even matter. So that is the syntax for writing insert. So insert into, table name, column names all in parentheses, values and all the values in parentheses. And because we've defined GPA as a float, you should not put that in single or double quote. So if you have defined something as an integer or a float, you cannot put them in single or double quotes. It's very similar to how we do it in Python. So after that, I'm going to use the execute statement to execute it. Okay, so if this runs without any errors, even now we still can't see if we have inserted data correctly or not. So we will get to that part pretty soon. But if it runs without any errors, let's just assume that it inserted the data correctly. So there we go, no errors. That means it's reconnecting. So maybe that's what it is. So anyway, All right, connection done, running is done, so no errors. So let's see, let's take a look at our students database, or no, I said college database. There you go, college database. And it doesn't have, we cannot really see a whole lot here. So that's fine. I'm going to make an assumption that it has inserted this table. And do it one more time. Take a look, college DB. So, all right, see, there's a lot of stuff here, and maybe some metadata might tell me something. There you go, John, something, something. It's not formatted the way that I can read, but it tells me that it inserted the row correctly. All right, so I can go into more variations of insert, but before I do that, I want to jump to select because we need to be able to view if our insertion is being successful or not. So I'm going to skip over to the next section and then I'll come back to the insert statements. So querying database with select statement. So we have inserted the data. Now, wouldn't it be great if we had a SQL statement that would select all that data and then display it for us? So the syntax or the statement here would be select. So the syntax, the SQL syntax is select star from whatever the table name is. And I will explain what star is in just a minute, but that's the MySQL syntax. So we know what we have to do when we have a MySQL syntax. We just put it in a SQL string variable, or this variable can be any name. I'm just using SQL for consistency. So I'm just going to grab it from there. And then instead of table name, I'm going to say this is student. So star signifies every single column. So if you only want any specific column, you can name that specific column here as comma separated. So if only I wanted name and CWID, I would have to correct it, spell it correctly, that's for sure. So that's how I can do it. If I want 3 columns, I would add another comma and put the 3rd column in there. But right now I'm using the simplest form of select statement, which is select star, which will select every single column of as many rows that are in the table. And then I will go execute that. And that's still not done yet. We still have to get the result. So far, just an execution was enough, but once we execute it, Python will give us what is called rows. So if we use a method called fetch all. So using the cursor, so far what we've done using cursor, we've used the execute method. Now we're going to use another method called fetch all, which literally fetches all the rows that this statement has generated. So if you have inserted 1 row, this statement will give you 1 row. If you have inserted 20 rows in your table, then rows will give you all the 20 rows. So for now, I'm just going to print the raw rows. Okay, later on we'll kind of try to format it better. If we understand the syntax or if we understand the structure of rows better, we'll be able to print rows better. All right, so as of now, I'm gonna have to do a from pretty print. From. There you go. That's it. So I selected everything, I executed the statement, I used the fetch all method. Fetch all method doesn't take any parameters, but it definitely needs the cursor. And then you can store it in a variable called rows. I'm calling it rows. You can call it anything that you want. You can simply call it data and print that. So it's okay. There's another insert statement. Okay, so we don't need to insert it again. So remember when we created the table, we said CWID is a primary key. So once we've already inserted a row with this CWID and we're trying to do that again, it is going to give an integrity error. That means, hey, you are trying to insert another row with the same CWID, and you cannot do that because you have designed your table to not have multiple values for that by calling it a primary key. So that's why this statement doesn't need to be there the second time I'm executing, because this row is already inserted. So just this error actually tells me that this row is successfully inserted. So anyway, so now let's start looking at our data. So there we go. That's our very first row. And the data is, so basically just by looking at the way my result is printed, I can tell data is a list. And it's not just a list, it is a list of tuples, and the first tuple has 1, 2, 3, 4, 5 values in it. The second one will also be a tuple, and again, that will also have 5 values in it. So list of tuples is what is returned by fetch all. So we will eventually figure out how to print it better. For now, I'm just going to use this raw format. So if I inserted another row here, this time, let's see, I'm not going to give a CWID at all. So because I've deleted one column value from here, needless to say, I have to remove it from the column names also. And maybe change the name, that would make sense. Loree. Okay, and she's from, let's say, accounting. I'm just making it up. No significance to this data. And her GPA, let's just say it's 3.55. There we go. When we execute it, this time it should print me 2 tuples. Okay, the first tuple would be John Smith, second would be Valerie. But guess what? The CWID, I'm not giving it any CWID. So let's see what that's going to display for us. All right, let's see. There we go. It printed me another tuple, and the CWID is auto-incremented. How did that happen? Because anytime in SQLite you specify a primary key as an integer value, and then in your insert statement, if you don't specify what the CWID is, then it will increment it. Whatever is the last CWID, it gets incremented by 1, and that is assigned as the new CWID. So in our very first insert statement, if we had not put our CWID at all, then it would have started with 1. So that's one thing to know. And the beauty of SQL is heavy lifting is all done by SQL. All right, so that's one variation of insert statement. Let's start looking at more. And so we need the create table. We definitely need the select table. So write all our create statements between these two. So let me go back and look at the next variation of, okay, so sorry about that. Another variation of insert statement is when you want to insert multiple rows. So the syntax would be very similar to single row insertion, except for, so you would have the insert into student, and here I'm only inserting 2 columns. You can insert as many columns as you want, and values. So in our previous insert statement, we had one set of parentheses with comma separated values. Here, you can have another comma and then add another set of parentheses with all the values that you want in there. So one caveat that you have to follow is all the values should match. So if you have 2 columns here, then each parenthesis set should have 2 values, corresponding values, separated by commas. So when you execute a statement like this, it will add 2 more rows, and guess what? Because we're not specifying any CWID, it's going to create incremented values of those CWIDs, and whatever else we're not providing, say in this case, our major and phone are not being specified, they will be inserted as null values in the database. But when you try to print them in Python, they're just going to be blank values. So let's try to see what that is going to give us. So as you can remember, the analog, the values corresponding to null in database are now none type in Python. So basically we can say that all of these phone and major are nuns, and this is a float, and guess what? The CWIDs are incremented. So we have 5 or how many rows have I inserted right now? Have I executed it twice? So basically, yes, because I'm executing more times, the same rows got inserted, but with different CWIDs. So the integrity constraint is not violated. So I shouldn't have done that, but oh well. So that's one way to insert multiple values in a multiple set of rows in a database. So inserting null data. So here, I am specifying. So what if we know some of the major values? Here we did not know any major values or any phone values. That's why we were able to just say, hey, I only have name and GPA. So what if there are some instances where for some people you know the major, some people you don't? So how can we write an insert statement with some having a major and some not having a major? So let's do that here and see. So same concept, insert into student is going to be the same. The column values are going to be the same. Now, if you don't know the major, we're going to put null for whatever values that you don't know for anybody. You can simply use, instead of empty strings or blank strings, you can use what's called a null. So when I try to insert all of these 3 people into that, now I'll have 3 more tuples here. I'm going to make sure I'm going to comment it out so I don't insert multiple students with the same name. So there we go. As you can see, the none type, none are being inserted into the database. So that's another variation of insert. These are going to be pretty much a practice. There's really nothing to teach here, if you will. The most important thing I want to teach today, the most important variation would be how can we insert variable names. These are all hard-coded. So far, we've seen everything is a hard-coded value. But what if this value were stored in a variable instead? So how are we going to make an insertion like that? So in that scenario, we are going to do it using a parameterized query. So for example, name is stored in a variable called name, and GPA is stored in a variable called 3.2, and in a variable named GPA, and CWID is 100, 800. All right, so I'm giving a whole another CWID. So the first step is to create what's called a tuple. So using these 3 values, I will have to create a tuple, and I'm going to call it a parameter tuple. Okay, so now my insert statement will not have those hard-coded values anymore, but instead it will have question marks. Okay, the question marks will be corresponding to how many ever columns or how much ever data you have. So here I'm giving 3 column names, so I have to have 3 question marks. If I had 4, I would have 4 question marks, and correspondingly this will be a 4-element tuple. It's going to be a 4-element tuple. Okay, last change that's going to happen is, up until now our execute statement only had 1 argument. Now we're putting a comma and we're passing it a second argument, which is the parameter tuple we just created. That's about the only difference here when we're using variables. So why do we have to use variables here, Ms. Suchi? Well, when you're reading data from a file, you would have to store them in a variable, and then you would have to be able to insert into the database. So that's kind of why this is the majority of the type of insert queries we're going to be seeing in this class. So first step, create a parameter tuple. Again, you can do all of this in one single step and not even have multiple stuff created for you. So there we go. We can do the second element is, the first one is going to be the SQL string. The second one is going to be a tuple with, in this case, 3 elements. So when I try to do that, it will insert Sammy Williams. And if you can note, it will not increment his CWID from the previous value. It has inserted this brand new CWID. So the next insertion will be incremented from this value. So the next CWID for any insertion, if I don't specify anything, it would be 10801. Okay, so that's about all the insertions. So you can try some of your own, and think to remember in this type of, whenever you do these question marks, which are pretty much called placeholders, this whole query is called a parameterized SQL query. All right, so now we have added a bunch of data into our database table. So let's see other variations of select statement. So right now our select statement is printing a very, very raw format, and we will see how we can clean it up into a nice tabular format. But before that, let's see the two variations of select statements. So select statement in its easiest form would be select star. Delete whatever I don't need here. I'm going to still keep my create table because it has the if not exists constraint. It's not going to try to create the table again. When you try to create it again, it's going to delete all the entire data that I inserted and it'll create a brand new. So if not exists constraint is going to prevent that from happening. So all right, so I'm going to leave the create and I'm going to leave the, so we're going to look into the select statement. So this is what we have seen so far. And the thing to remember is fetch all method returns a list of tuples. So we have seen the entire, this whole thing is a list. And in that list, the first element is a tuple. The second element is so it's a list of tuples. So instead of a star, you can specify, hey, I don't need everything. I just need the name. So if you can just give one column here, and if you run it here, your tuple is going to only have the names of that person. So 0, 0 will give you the name, and 1, 0 will be the second name, 2, 0 will be the third name, so on and so forth. So if you want name and CWID, then this is how you're going to specify comma separated values, and it will only retrieve the values that you're asking for. So this is if you want to limit the columns. What if you want to limit the number of rows? Because no matter how many columns you're choosing, it is still giving you 12 elements. What if I don't want 12? I just want some subset of rows that follow a specific criteria. That's when we use what's called a where clause. So where will tell me that if I have a condition. So if you have a condition like I only want students whose GPA is greater than or equal to 3.5, that's when you will use the where clause. And then this may or may not return all the rows. If only a few people fit that criteria, then it'll only return that many rows. So I'm going to run it again. There you go. So only one person fit that criteria of GPA greater than or equal to 3.5. It only returned us one tuple. What else? So here also, we can use a parameterized select query using the where clause. So instead of this, say for example, you want the power with the user wants to decide, hey, I don't want to hard code this as 3.5. I want to decide what is the threshold of the GPA. So in that case, let's say the user says user entered GPA is equal to, let me write an input statement here, okay? Enter GPA. And then we're going to ask him, of course, we're going to have to do conversion of a float. And right now, we're just going to assume the user is going to give us clean values because I don't have time for validation in this video. So, and instead of 3.5, just like we've done before, we put a question mark, okay? And then in this, we're going to pass it a tuple. I'm going to call it a parameter tuple. I haven't created my tuple yet. So the tuple will be a tuple of whatever the user gave me. But remember one important thing. Whenever you're creating a tuple, you cannot just put parentheses and one value. If your tuple has only one value, this is not the right way to do it because this is still going to be considered as a float. But if you put a comma here and then you don't even need a space. If you put a comma, that tells Python, okay, this person's intent is to create a tuple. It just happened to have only one value. So there we go. I'm going to match these names so I don't get this error. So I created my parameter tuple. Earlier we had 3 elements, so we didn't have that problem. But anytime you have only one value and you want to create a tuple, you want to put that value in there and then you want to put a comma. There we go. So here I changed the value to a question mark. So if I execute this statement now, and now I'm going to ask the user to give me a GPA. So these are going to stay, okay, 2.3. Now it has pulled up a lot more than before with all of these people who have GPA greater than or equal to 2.3. So that's a select using parameterized query, and in this where clause, you can have multiple. I can also specify and, well, GPA less than or equal to 3.5. So 3.4, let's do that. So GPA greater than whatever the user gives, but less than 3.4. So if I run this and I provide a GPA of 2.0, it's going to give me anybody who's between 2.0 and 3.4. And that's why all of these people didn't qualify for that. So this where clause can be very, very complex. You can do a lot of combinations, permutations, and combinations of different columns. It doesn't even have to be the same column. You can also say, and CWID greater than 100, 700. So it may not, it should technically pull up only Sammy Williams in this case. So if I run it and I provide 2.0, and Sammy Williams is the only one that qualifies because he has a CWID greater than whatever I've specified here. So basically so we're not going to look into very complex SQL statements in this class for select statement. We're just going to keep it very basic, very simple. So I'm going to delete all of these. But if you are taking CINS 3006, you are welcome to try any SQL statement here and it should work correctly. All right, the last thing is sorting. So yes, you got your data, but what if you wanted to sort? So right now, all of this data is unsorted. What if you wanted to sort by their name? So then what we use is order by, and then we have to give it a column name. So name is our column name. Again, I told you that even though we have defined name with an uppercase N, here I'm using lowercase, all lowercase name. Python really, SQL really doesn't care because it is case insensitive. So order by name, if I don't specify anything, it will do an ascending order sort. If we do it, all right, let's go ahead and run that now. And then I will also take off this constraint here. So there we go. All of this are sorted by their name. I will remove this for 1 second. Just hard code it so I don't have to keep entering the GPA. All right, so no more parameter tuple here, just the SQL string. Now, if I want to do name by descending, I have to use DESC. I don't have to make it uppercase, but remember our convention that anytime we're using SQL reserved words, let's try to keep the case upper. Okay, so if I do that, now it's going to do the opposite. So V comes first and so on and so forth. Instead of descending, if I specify ASC, that's ascending. If I don't specify anything, it defaults to ascending, but I can also specify ascending. And here also, I can do a lot of permutations and combinations. I can sort by name ascending and GPA descending. Okay, so when I do that, it'll order them differently now because it's name ascending and GPA descending. So a lot of permutations and combinations here also. We're not going to go into that level of detail. And the last variation of select statement is to get the aggregate. So just like we've seen sum and length in our lists and dictionary, we can see some aggregate function here. So because we have a GPA, we can select, hey, how about I want to know the average GPA of the students, right? So very simple statement to do that is going to be AVG. AVG is a reserved function in SQLite, and I think Oracle is the same thing, or maybe it's average spelled out in Oracle. I don't remember, but you can give the column name. Just make sure the column happens to be a float column. Okay, you cannot do average on text column, so you cannot do on any of these. But because GPA is a real data type, you can perform an average. So in this case, you can use fetch all, but we have to know that average is an aggregate function. It will only return one row. It will only return you one value. You're only getting the average of the GPA. So it's going to be one number. So in that case, instead of fetch all, we use what's called fetch one. And that's it. So right now, let's see what the data is going to look like when we do a fetch one. So there we go. It's a tuple. So when you do a fetch one, it's not a list of tuples anymore. It's just one tuple with one value. So if you just want to print this value, how would we do it? We simply would do that, and it'll print a float value of 3.288. It won't print the whole tuple. It'll just print the float value of this one. So you can directly use the print statement to do that for you. And again, we can round it inside the print statement using the round function, comma 2, and then we'll round it to 2 decimal points, so on and so forth. So other aggregate functions that we can look at are sum, min, max, count. So instead of AVG, if I simply did sum, it will give me the sum of the GPA for whatever reason. I don't know why you want to do a sum on that. And if you want to see who has the lowest GPA, or what is the lowest GPA, then you can do that. And then you can see 2.78 is the lowest, and you want to see the maximum. You can also see maximum GPA from the student table. You can see the maximum is 3.55, so on and so forth, all fun. Last one is count. Well, count is especially used when you have a where clause. Okay, so if you want to say GPA greater than 3.4, I don't want to know who they are. I just want to know how many students have a GPA greater than 3.4. And we have seen that it only one student qualified for that. Okay, so 6 students have a GPA greater than 3.4. If I do 3.5, I think it's only one student that qualifies for that. So if I don't want to know who they are, if I just want to know how many there are, then we use an aggregate function called count. So that's about all the variations of select statement. So we can select the data to view the data inside the database. That's all great. So we have created data tables, we have inserted data tables, and we have retrieved the data. Now we are starting to update the data. So what if I want to change the data in an existing table? So that would be update. What if I want to delete the data? That would be delete. So we will see that in the next lecture. For now, this is all I'm going to do. So that makes sense.
Hello, so this is the last lecture video for Chapter 14, Database Programming. So far, we have seen how to insert data, how to select data. Now we're going to see how to update that existing data in the database and how to also delete some of the data rows and maybe all of the data rows. So let me go ahead and share my screen. So we're going to be seeing how to do updating rows. I'm going to do everything between my select statement. Actually, instead of this, I'm just going to do select star because I want to know how my update statement has affected things. So very simply, I'm going to select all the rows from the data table, and I'm going to have one of this here. So this is going to be fetch all and just data. I'm going to do one of that before, one of that after the update statement to see how the update statement has affected our table data. So, so for example, what if we wanted to update a student's GPA or their name or their major and change it to something else? So we've done that using programmatic approaches when we had lists and dictionaries. So how would we do it if it were a table? So the syntax, the statement is called an update statement, and the syntax for update, the SQL syntax is update, and then you provide the table name. Then you use the reserve set, and then you give the column name that you're trying to update and the new data value. So we don't care about what the previous value was. We're just providing it a new value. And then if you have multiple columns that you're trying to simultaneously edit, then you would put a comma after this and then put another column name equal to data value. And where is optional, but you can use that if you have a certain criteria. So we've seen in our last lecture that where conditions can be very complex, and so that applies here too. So for example, given a scenario to change the GPA of a student whose CWID is that from null to 3 points. So we don't really care what their original GPA was, we just want the new one. So for that, the SQL statement would be something like this: update, the name of the table is student here, and then we use the set keyword, and then we say GPA is the name of our column when we had created, and equal to whatever is the value. And because it's a real or a float, we're not putting it in single or double quotes, we can just provide it as is. And then in the where clause, we're telling, okay, whose CWID are we trying to update? And that would be CWID equal to 1000, 700. And when we execute that statement, it should, so let's just do that before and after execution. We can see how it's going to work. So let's go ahead and run this code here. Okay, print is not a very good idea to visualize the data. So let's just do switch print for print for the next ones. So, but as you can see, if you can find out 1000, 700, do we have anybody with that at all? I'm going to run it again just to make sure. Do I have any CWID with that corresponding CWID? I don't. So let me add one. Let's see. I'm going to use for Gabriel Webb. I don't see him having any CWID. So 1000, 110, 110. So for this student, I'm going to set the GPA to 3.0. So when I print it again here, first it'll show none, and the next iteration, it'll show me the new GPA installed. So there we go. So originally it was none. I don't know which of these is GPA, but then after the execution, we're trying to print them all again. So when we see here, then Gabriel Webb now should have a GPA of. So there you go. We can successfully verify that our update statement has worked. So what else can we use? So using row count. So here, in this case, because we said CWID is equal to 1, we know for a fact that only one row is going to be updated because CWID is a primary key, and we know it cannot have duplicate values. So there will be only one, absolutely one student that will correspond to this change. But what if you are updating multiple rows and you want to know how many rows are affected by this change? So for example, let us set all the null GPA to 0. So as you can see, there are a bunch of nuns, none types for GPA in this data, like you see there, and so on and so forth. So if we were to make this change, how many rows are going to be updated? If we want to know that, then we use something like, we can use the same SQL format with the SQL string where set GPA equal to 0, where GPA, so we don't use equal to, we use is null in MySQL. And then we execute that statement, and here using the cursor, we can print the row count attribute. As you can see, row count is not a method. We have used fetch all, but fetch all is a method. How do we know that it's a method? Because of the open close parentheses. And we have done fetch one. Fetch one also has open close parentheses, but row count is an attribute. That means it's a variable. It doesn't have open close parentheses. So if I make this change, how many rows are going to be affected, and that's what we need to know. So I'm just gonna, well, it doesn't matter. I think I'm gonna leave it there. So it can print me all the rows before, all the data from before, and here it is telling me 2, which is 2 rows were affected, and now instead of having none, I will just have 0.0, 0.0. So that is two variations of update. Again, update can be very, very complex. Right now, we're only updating one column. We can update multiple columns here. We can have a very complex conditional or criteria here. We're going to stick to very simple stuff. So that's the update. So that is how we update an existing data. So to be able to use update, there has to be some data in the table. Next is deleting rows. So what if we wanted to delete some data or some rows that fit a certain criteria? So for example, to delete all the rows with GPA 0, which would technically be this row and this row, if we want to say, hey, I don't want to keep any student that doesn't have a GPA, that's not applicable to my situation, then we can delete using the delete statement. So just very similar to update, we use delete. So compare and contrast. Update, here it is delete from. There's an extra word, keyword here, from, delete from student. And then there's no set. Update had a set. Delete doesn't have a set. It simply jumps to where clause, where GPA equal to 0 or 0.0. It really doesn't matter. And then we can also print how many rows were affected. And we know for a fact that only 2 people were there. So when I execute this statement, initially it'll print 11 or 12 tuples, and then it'll print 2, and then when it prints again, it'll only have 10 tuples. So let's see if that's going to happen. So there we go. So in the beginning, it printed me 12 tuples, and then it printed that 2 of the rows were deleted, and then now it's showing me all the rows in the table, which is at this point only 10 rows. That is how we delete data from a table. It's really simple, and we might be able to play with some more later on, some more variations, but delete from table name, where, any criteria. So if you happen to accidentally do that, delete from student, and you do not specify a where, that means it's going to delete everybody from the table. So be very careful when you're using the delete statement. So that's about all that is in this video. So I hope that makes sense.